Hello and welcome to SciLux, the podcast where we talk about scientific developments and technological changes in Luxembourg. Happy New Year to everyone. This is one of the first episodes in the new year, so I'm very happy to come back to you and record again discussions about science, of course. And as you heard, today we're focusing again on Luxembourg. So we'll be having a Luxembourg-based researcher. This also means that this episode is proudly powered by Research Luxembourg, and we are recording at the Media Center of the University of Luxembourg. And who is our guest? Well, it's Silvia Venditti, who is an environmental engineer with a PhD in chemical engineering from Imperial College London. She has worked in many research institutions and is currently at the University of Luxembourg. Nowadays, she specializes in nature-based solutions applied to the removal of micropollutants, and the ultimate scope of her research is reusing water and fighting pollution. Silvia, thank you so much for coming today.
Thank you, Hannah, for having me.
We are actually tackling a very big subject and only a little bit of it as well. We already had a researcher from a list where we talked about water, but we were talking about water on the moon. So this time it's not on the moon, it's here on Earth.
Yes.
It's terrestrial, but there's still a lot to discuss. But what we're talking here about more is wastewater, right? That's what you're focusing on. So let's start with nature-based solutions. I want to define them first because this is something we'll be discussing a lot today. So what are they?
They are approaches to restore key function of ecosystem and to protect the health, but ecosystem in general. And I would say the most interesting thing is to remind ourselves that actually nature is the most powerful engineer. And what we do with a nature-based solution is just to copy some key function that nature uses to really function. And as engineer, because I'm an engineer, so this is what nature-based solutions are. But there is a huge variety of nature-based solutions that can be used for multiple purposes. In my case, I'm focusing on the treatment of wastewater. But I would say that the most known one are the one implemented like in urban area to fight climate change or to keep humidity when there is dry weather, to bring back biodiversity. So it's really multifunctional.
But you mentioned you're an engineer, so I was wondering, when you study engineering, is it something that is very present and very important or not really?
Absolutely not. So I graduated in 2010 with my doctoral degree, and I was never thinking that my future research or work would be nature-based solution. So I was designing a complex treatment of wastewater with pump, hardware, and big stuff. But I was never thinking to do that. And so when I was offered with the postdoc position at the University of Luxembourg, I was thinking, oh yes, this can be really, I always call it like the cherry on my cake. And I have to say that it was really challenging. It is challenging because I'm still an engineer. I still think as an engineer, but the nature-based solutions are really pushing me out of my comfort zone because you really have to understand things that are not part of my education, like microbiology, for example. So in nature-based solution, you have the synergy of many mechanisms. In general, the one that we design or that I use for water treatment, they have many components. They have soil, they have a type of plants which can uptake pollutants or they can help the removal of pollutants. And then you have the action, for example, of the light, because nature-based solutions are exposed to UV light. So there are many mechanisms. But the strongest one is the biodegradation that occurs inside the nature-based solution, especially in the soil, and is due to the presence of the microorganisms. And there, engineers have zero control. So for me, it's really challenging, but also fascinating. And I love to bridge with other disciplines. And I think to use nature-based solution efficiently, you really have to do that. You have to bridge with microbiologists, with plant experts. I have a zero green tools. I can kill everything at home. And still, you need to use your engineering approach. You need to operate them efficiently and to choose what you can choose as designer, like the type of soil, if we want. And also there, I'm not a soil expert. I had to learn a lot about the soil science.
So before you tell me how it is not to be in control, as you called it, I just wanted to look at the pub quiz question you prepared, the cherry on the cake for other people, we could say, right? So the nature-based solutions and the job market, we could say. So if you could ask the question right now, and listeners, remember, answer only at the end of the podcast.
Considering that nature-based solutions are multidisciplinary approaches to protect, conserve, restore ecosystems, which can be modified terrestrial ecosystem or freshwater, can you guess how many new jobs can be created by 2030 if we will invest more in competence building on nature-based solutions?
Great question. I just have to make it precise a little bit, create it on the European market?
Globally, sorry.
Globally. I think globally will be, yes, because we could think of Luxembourg, which probably is a smaller number, but then we go globally in this case.
It's globally.
Okay, perfect. Remember, answer only at the end of the podcast. And now coming back to the control, as I called it, right? So if you're an engineer, at least essentially for me, it is a little bit of, okay, I design a machine or I design some kind of a tool. I put the metal in and the other parts, and then I check it works, it doesn't work, I improve it. But here there's a lot, first of all, the knowledge, but also if you're using nature might say, no, sorry, I don't like it. I'm not going to work the way you want, right?
Yes, in fact, it happened that I was testing the same design of nature-based solution, duplicated, and one was working well and the other one not. And I still cannot say why. I have a guess, but sometimes nature wants to do something else. So there is still a bit of variability, but I think when you know more and when you have in your hands the key elements of nature-based solution, you are still able to control in a way. For water treatment, we normally choose one type of design. We are speaking about constructed wetlands, which are a design man-made to really decrease pollution and to treat a different stream of wastewater. So they are really versatile and already applied since long time everywhere around the world. And one of the main advantages that they are low cost, that they don't require high maintenance. They are incredibly resilient. This is also the reason why they are used in development countries. But you need space. And we know our land costs also in Luxembourg. And the question is here now, why we should introduce nature-based solution in Luxembourg? Is really possible that? This was our motivation when we started in 2017, because my focus is to use nature-based solution to reduce the impact of micropollutants. Do you know what micropollutants are?
No, I don't.
So micropollutants are pollutants that can pose harm to the ecosystem and the environment, even when they are present at very small concentration. We are speaking about nanogram, microgram, and they are coming from all the chemicals we use. Pesticide, herbicides, these are the typical micropollutants that are present in our environment, but also pharmaceuticals. While it's easier, let's say, to stop the use of some pesticides, you will not say to somebody that is sick not to use pharmaceuticals because you know that this will bring some harm to the ecosystem. So there is also an ethical issue in this sense. So what we have to do is to treat the water end of the pipe before we discharge it into surface water. Since some years, 20 years, we realized that micropollutants are dangerous for the environment. The scientific community was really keen and looking for a solution to reduce their entry, because they are present in wastewater. And wastewater is what we produce with the consumption, industrial consumption, but also human consumption in our daily life. We use fresh water and we produce wastewater, and we discharge wastewater through wastewater treatment plant. Yeah, but the conventional wastewater treatment plant are not able to remove these micropollutants because they were not designed for it. They were designed for nutrients, for example, nitrogen, phosphorus. So what we had to do, we had to find solution to reduce this emission of micropollutants into receiving water bodies. And typical high-tech engineering machine were ozonation, UV irradiation, or activated carbon, definitely not a nature-based solution. And why we started to test them in Luxembourg? Because we thought that nature-based solution would be a suitable alternative to the conventional high-tech technologies to reduce micropollutants in a region where we have small agglomerations, small rivers, but where you still want to have something that is fully integrated into environment. And we discovered that it works.
So there's a good story behind it as well.
Yes.
But, in this day and age, it's all about convincing people about the high-tech solutions, as you said, and innovation. And I think it's so difficult to sell nature-based solution as innovative, isn't it?
Yeah, you're perfectly right, because they are an old technologies. So we use nature-based solution constructed wetlands since 25, 30 years. And is convincing the policymakers that it's safe to use nature-based solution, that is cost-effective. It's still a long way to go, but we are in this direction because wastewater discharge is regulated in Europe with the Urban Wastewater Treatment Directive. And this directive is active since 30 years. And for me, it was the revolution, the environmental revolution since 30 years, because it really increased the quality of surface water. The directive was just updated in it's now almost 1 year, and there is a strong push for the use of blue and green infrastructure, which includes mainly nature-based solutions. So there is also the push of the policymakers to use nature-based solutions when it's possible, like for the treatment of stormwater runoff, like also the treatment of wastewater if you have a small agglomeration. But all the factors have to be balanced. And I think the research that we did until now was producing results that are confirming that we can put our trust in nature-based solutions, and that the Commission is also right on that. So there are also more fundings for this.
So that's good news. But
yes.
I was just thinking to structure it a little bit, because when we talk about waste in general, it's very conveniently put somewhere so that we don't see it, right? Yes. So people know that theoretically that water that they've just used is going somewhere, and they know that probably then it's kind of, treated and something happens, but it's not that you go and visit such as, water treatment plant, right? It's normally not put in a place where you can see it, right? It's, at least I don't see it on a regular basis. I know more or less
But you
where
would be
it is.
surprised, because there are nature-based solutions in Luxembourg.
Exactly. So tell me, where are they? Where can you see them?
For example, in Belval, in Ramerich, there is a nature-based solution that is treating stormwater runoff. And it's just close by, but nobody knows that is a nature-based solution. It's fully integrated in the landscape. There are also other nature-based solutions along the motorway, still to treat runoff from the motorway. Other type of nature-based solution for wastewater treatment are, for example, if I'm not wrong, in Burlingster, there is an aerated pond. Nobody knows that is a wastewater treatment plant. And this is the beauty of nature-based solution, that they are fully integrated.
Yeah, not like other plants that's kind of,
yes,
you really see them, right?
For example, another very, very interesting one is in the city of Stansford, which is close to IKEA, no? And is also treating runoff from the roof and from the street. And there is a recreation area. You can walk there with your bike, and you have no idea that this is actually a treatment plant.
Okay, that sounds good. So people, if you want to visit, from now you have different points to kind of realize it's happening already, but it's not fully integrated, let's say. It's not the classic way of treating water in Luxembourg. No. Exactly. So the usual way would be a plant that is treating the water. So if I am, for example, using water in my household, what happens with it? It goes through the pipes?
Yes, it's collected and in canalization and is delivered to a centralized wastewater treatment plant station. The most common wastewater treatment plant are with activated sludge, which is already something nice because it's a pool of bacteria. So the process to treat wastewater is really through the action of bacteria to a biological step. This is the most conventional, well-working design of wastewater. Normally you have a wastewater treatment plant that is collecting the wastewater of several small towns, which is the case here in Luxembourg because we have small agglomeration. And the wastewater treatment plant is then discharging the treated water into the receiving water bodies, which are rivers, the Alzette, the Sur, and so on. This is the most conventional treatment.
But sometimes, like in your research, some of the things that are in the water you can also reuse.
Yes, because exactly this, we have to change our mindset in a way and our way to work that you take, you consume and you waste. We have to really to try to use a circular approach, to try to recover what we can recover from waste, for example, and to produce valuable resources. And this is the case also in our wastewater treatment plant, and there is also a strong push from the European Commission that we change the way in which a wastewater treatment plant works. We want to transform wastewater treatment plant into factories. You can recover valuable material from wastewater treatment plant and produce products. For example, you can recover carbon-based material, which can be lipids, which can be cellulose, which can be volatile acid, to produce, for example, biofuel, biodiesel, or acetic acid, or also something else like biochar. And it's true that the most studied or the most valuable material that is recovered from wastewater or from activated sludge is traditional phosphorus. But there is much, much more that we can do, like with cellulose. Cellulose comes to the wastewater treatment plant through toilet paper. Do you know how many toilet paper rolls a human consume per year?
Not at all.
Not at all. So we consume 85 rolls of toilet paper per year. And toilet paper has a lot of cellulose material. And this is really the valuable material from the toilet paper. And the cellulose could be converted into valuable products like acetic acid, but also biofuel or biochar. And there is a big potential because normally the cellulose, it's collected at the beginning of a wastewater treatment plant where you have a screening that is stopping the big material to go through the biology of the wastewater treatment plant. And what happens with this? It normally goes to incineration. So it's completely waste. If there is potential to recover cellulose from this dry material, then it's common practice to waste it completely. And in one of our research projects, what we did, we studied the conversion of this cellulose, if it's possible to recover this cellulose into biochar. And this is really possible. And what we did next, we used this biochar in nature-based solution. Because the biochar has the potential to absorb some of the micropollutants, for example, some pollutants, but can also be a carrier of specialized bacteria if it's mixed with the soil, and that can really help the removal, the global efficiency of the treatment. So this is really what we did, and it's really like closing the loop. Yeah, you recover something that is valuable and you reuse it still in the function of a wastewater treatment plant to remove micropollutants, for example. And we have been very efficient with that.
That sounds very good, but I'm just thinking this would mean having a solution to stop only cellulose from going further, right? Because you said the first kind of a step of the water treatment plant is to, stop the big things that then get
this
burnt.
has to be done anyway.
So it is already sorted.
It is sorted, but it's not recovered. So the cellulose, the big material, or the toilet paper is removed to make the treatment in the liquid phase of wastewater efficient and is normally incinerated.
And it's not mixed with other materials?
Normally not.
It would be rather clean, let's say, cellulose, if you can call it this way. Okay.
Yes, what we did in our study, we mix it with other material to create several variations of biochar to see which one is more effective. But we mixed it, for example, with wood waste. So anyway, we wanted to create a sustainable product from waste and trying to do our best to recover cellulose from wastewater.
You talked about biochars. I think it's also good to say what it really is exactly. I have to say that the first time I heard about biochar was during a startup pitching session for space, because one of the scientific parts I'm really interested in is space research, of course, and biochar was there mentioned as well, of course, using some space-based applications, but that's a different story. We're again on Earth, we're not going to space. And talking about biochar as such, what is it really?
It's a material that we create after pyrolysis. So thermal treatment of our waste. With pyrolysis, you reach between 600 and 800 degrees, and you create this material that has a certain porosity and a certain surface area that can be used for absorbing pollutants. And we can compare it, for example, with activated carbon. Many people are using activated carbon filters to filter drinking water, but it's used in general. Granulated activated carbon is produced at much higher temperature from coal, for example. But what we do with the biochar, you normally use waste and you use a lower temperature to produce this material that you can reuse. But normally, after pyrolysis, the biochar needs to be activated to really increase the surface area of the material, the structure, to make it more effective. And what we did in our study, we activated with bacteria by fermentation to make it suitable still for nature-based solution. This is the engineering approach with the nature-based solution. You try to intensify their design. And you can do that, for example, selecting the appropriate material or boosting the soil with something powerful that can be the biochar.
So in your case, is it more about finding new nature-based solutions, or is it adding something different to them?
Until now, it was modifying what we know already and adapting, because micropollutants, this was my focus, they are really recalcitrant pollutants. Very difficult to remove with the traditional mechanism. And so we had to adapt the nature-based solution in a way that we can increase this efficiency towards these pollutants that are really resistant. And so this adaptation came from with the only mechanism that we can control a bit, which is sorption or everything that is related to soil, let's say. There we can still choose. We can choose how to operate it, but we cannot decide what the microorganisms are doing inside the box. Yes.
You're calling a lot of different elements micropollutants. Does that mean that the solution you're developing is going to work for all of them? Can we put them in one box? Because, I'm just thinking about a long time ago, I had a colleague of yours from LCSB this time, Professor Emma Szymański, that I think you also have a project with, right?
Yes.
And she's on to unknown chemicals. So there's so much going on in wastewater that I don't think you can just apply a fit-all solution in that case, right?
Yeah, you are perfectly right. And this is the scientific human question, because who is deciding which micropollutants we should focus on? And if we have a list, is this list really representative of the pollution? Just to come back to the Urban Wastewater Treatment Directive, you have to know, and this is really unique, that it's the first time that we have 12 compounds in a directive that the wastewater treatment plant are obliged to comply with this list. And you also have to know that in Luxembourg, we had, in 2020, the Administration de Gestion de l'Eau was releasing guidelines with 4 mandatory compounds. So Luxembourg was one of the first countries in Europe. But they are not representative of the whole story. And this is also the reason why non-target screening is important. And that's the reason why I work with Emma together. And also combining screening with a toxicity test or more general risk assessment will really help to understand if our solution is able to offer an effluent that is safe.
Yes,
independently from...
Yeah, it's a bit of a chicken and eggs question, right? Yes. Exactly. I remember when Professor Szymański was here in the discussion of the list of PFAS, and it's really like a holy grail kind of thing that is just, I keep checking and it's just increasing, obviously.
It's increasing. It's just increasing. It's not decreasing. This is also a bit like with the watch list of the Commission, Now we are at the number 4 watch list, and the blacklist of the compound is just increasing. So you need to also have another approach that is not only target-based.
Okay, good. Leaving it there, I think we discussed enough household water to also mention the stormwater that you look at as well, right? So I just assumed that it rains and that's it, and I don't need to care about it too much.
No. And now, still with the Urban Wastewater Treatment Directive, we really need to consider also the treatment of stormwater. Or we need to have a plan, what we do with stormwater. Until now, the approach was to contain it. No? We collect stormwater in basin, for example, and it was more related to the volume. And we thought, okay, it's raining, rain is clean. It's not clean. It's clearly not clean. And this is also the reason why we need to look to the quality aspect. And it's also the reason why I have this project that is funded from the FNR. And this in collaboration with an engineering office in Luxembourg, with LuxPlan, where we design a nature-based solution that is able to clean the stormwater from street runoff, since we have a lot of traffic, we know that. And for example, there are micropollutants that are additive of the tires that are discharged with no control. And this kind of nature-based solution will be also a safe volume and quality treatment of the stormwater before the discharge in sensitive river like ours.
But it means we're looking at the water, as you're saying, from the street runoff. It's because there is a trend that people are collecting rainwater themselves, right? And that is different, the quality of the water you get, let's say, on your rooftop rather than
it depends as well, because in another project we also look at the runoff from the roof and of an industrial area, and the water is not so clean. So it always depends what you want to do with the water. Can we reuse this water? What should be the quality standard for the reuse of rainwater, collected rainwater? So it really depends.
Not for drinking, I guess.
Not for drinking, no.
You wouldn't suggest
but maybe in the future will be the case, because with climate change, we are going in the direction of water scarcity. We cannot just take, consume, and waste. We need to start to change our mindset and to reuse the water when it's possible.
It's a very good point. I actually read a book, unfortunately in Polish, so I cannot, only for the people who speak Polish, I will share the link. And the title is exactly Water. And it is more focusing on the situation of water in Latin America and also privately owned, resource. It's really fascinating. Again, a world that was unknown to me and what is happening there. And we will feel it more and more. We're still comfortably staying here in Europe, right?
Yes.
But still, it's very, very important that we get it into discussion. And of course, all the circular economy and solutions like that are really, really important for sure. Okay, other projects, because I have a feeling that we only discussed 2, but there's a lot of cooking in your pot.
Well, if we want to still keep going with water reuse, I have to say it's true that in Europe are mainly Mediterranean countries that are affected from water scarcity, and they have a policy in place since 20 years already, like Italy, Spain, they reuse water. Things are changing in Luxembourg as well. Because do you know that the highest consumption of drinking water in Luxembourg comes from household? It's not industry, it's household. So if we have to save water, we have to do it at home. And do you have an idea about how many liters of water you consume, for example, per day?
Probably too many.
So we consume, in average, 120 liters per day of drinking water. Because we are actually very lucky. We are connected to safe water. We are also, this is regulated from the Commission, that the water that for human consumption has to have drinking water quality standards. So very high standards. And at home, you open the rubinet and you use this water for everything. But actually, the high quality of water should be destined to drinking. And we only, of this 120 liters, only 4% is used for drinking. 35% is used for shower and 27% for flushing toilet. So the question is, do we really need to have drinking water quality to flush the toilet?
It's a very good question, and we know the answer, I guess.
Yeah,
right?
And I can tell you that the Administration de Gestion de l'eau is very sensible to that. And we have a project in the north of Luxembourg, in the Lycée de Clairvaux, where we use nature-based solution to treat the water coming from the shower and to reuse it for toilet flushing. If we could treat this 35% of water coming from the shower to flush the toilet, we will save 27% of potable water.
Of course, but do we need to treat it really? Do we need to treat shower?
We need to treat it. Well, we are now testing how polluted it is, but normally there are some requirements in terms of presence of bacteria like microorganisms and others to be reused for flushing toilets.
Practical way, how do you do it in that lycée? I mean, you just change the piping system or?
No, the school has already a system. In theory, yes, if you have a new building, you need to separate, no? In this case, we focus on the water coming from the shower of the swimming pool. So the piping was already separated. So they already had a system to separate that. And the idea of the Administration de Gestion de l'eau was to test nature-based solutions because they are really robust and resilient, and they don't need a lot of maintenance, so will be nicely integrated in a building. But conventionally, yes, you normally have one pipe and not 2. So this will change also the construction sector.
Small steps.
Small steps. But if you consider that 60% of the drinking water nationally is consumed in the household, if we could target this 60%, then we could be able to save a lot of potable water.
Of course. So appeal to other decision makers to continue testing and trying for sure these solutions. But one more thing, we're jumping a little sometimes with my guests when you have different type of, projects. Yeah. So we jump a little bit just to show what other things you could do. I wanted to know something about the We Treat project as well. Yeah. So that's new plants in Luxembourg testing. What is going on? What is tested there?
So the We Treat project is co-funded from the Commission. I think it's the first water for all projects in Luxembourg. So we partner with Portugal, Italy and Netherlands, and we want to design a nature-based solution to treat micropollutants. It should be a nature-based solution that is added to the existing wastewater treatment plant. So it should be only a polishing step for micropollutants. And the interesting thing of the We Treat project is that we come in with this experience that we were building over the years on designing new nature-based solutions, but our partners are experienced in phytoremediation, which is the power of plants to uptake pollutants. Because in nature-based solution, you have a soil and then you have plants. And as I said, I'm not an expert at all of plants, but my project partners are. So the partners in Italy and in Portugal, they will cultivate in vitro certain type of plants. We will give, of course, the priority to plants that can be grown regionally, and we will test this new configuration in a different climate conditions. So we will have a pilot plant in Netherlands and a pilot plant in Luxembourg, not so far in terms of rain events, but different conditions.
Okay, so this is one of the new things that are happening. So in a few years, we'll discuss how it went and we'll remember to share the results so people can see. I know you will for sure, because that's also part of doing research. You have to tell what happened and what were the results. So one more thing we did not discuss is the drinking water, right? So where does it come from in Luxembourg, actually?
Well, it comes from groundwater, and it comes from the sewer storage lake, which is very, very important in Luxembourg because it's a recreation area, because there is the power station, and especially because it supplies us with drinking water.
And high-quality drinking water on top of it.
Drinking water. And this is also for all this reason, tourism and power, that there is strong need to preserve the quality of the lake. And this is where the QualiSure project comes, where we want to identify hotspot pollution around the lake and implement nature-based solution there.
Okay, I think this is the moment to just leave it there. I guess people got more or less the idea of what is happening with water in Luxembourg and what needs to be done still, because of course there's still a lot to do, which means that we're coming back to your pub quiz question right now. So if you can remind our listeners what the question was and then give us the answer.
So, considering that nature-based solutions are multidisciplinary approach to protect, conserve, restore any ecosystem, can you guess how many new jobs can be created by 2030 if we invest in competence building on nature-based solutions?
And the answer is?
32 million new jobs globally.
That's a lot. So I guess there was a study about it, right?
Yes, there was a study. There was an estimation due to the fact that nature-based solutions are predominantly applied in development countries, but there is still this strong push in Europe and in US as well. And so this estimation was done considering all the people that are scatterling, working on nature-based solutions around the world.
I don't know whether you'll be able to answer this question, but does it mean you can actually study it as well? Or it's rather you, I don't know, as you're an engineer and then you start specializing in it?
Yes, so there is a new trend. Most of the people like me got in touch with the nature-based solution actually after university degree. But I have to say that my project for my engineering degree in Italy was actually a nature-based solution. Permeable reactive barriers are a nature-based solution. But at that time, I was not aware yet. I think it comes later. Because you have your own base degree, and then you can challenge yourself afterwards. But I saw, especially in UK, that there are meanwhile post-degree masters or release a portfolio of selected lecture targeting nature-based solutions, trying to tackle all the aspects.
And this way you can also develop, yourself as a researcher, right? Because of course it's great to specialize and go deep in, but nowadays I think that the future is all about interdisciplinarity and actually being able to work across domains, and the same for schooling, by the way.
Yes. For example, for this project still in the Lycée de Clairvaux or any other water reuse project, we can do the technology. I think we are pretty good on this. But can we convince the people to reuse the water? And there, we need social scientists.
Yes,
So
and science communicators too.
Science communicator, yes.
Just talking about my field a little bit, obviously, right? But it's always very, very important. And of course, thank you so much for sharing this a small part of your life, your working life with us, and continue doing what you're doing because it's very, very interesting.
Thank you very much.
And this is it for today. Don't forget to subscribe, to follow us. We are present on all the social media and, of course, on all the major podcasting platforms. If you want to suggest guests, remember that we're also on Patreon in case you want to support us there too. This was Silax, and my name is Hanna Siemaszko.